Hey guys, this is going to be the first video in this series of machine learning, or to be more precise, in this series of hands-on machine learning. So the whole series is going to be about 70% of coding, and that will be in Python, and the rest 30% will be the theory. I know theory bores people, but again, this theory is really important to understand the 70% of code which we are going to write. Okay, so I hope I can achieve this by the end of the video, by the end of the series rather. And so let's begin. So again, a disclaimer, this is a complete theory video because it's the first one and we know nothing about machine learning as of now. So we'll have to learn some theoretical stuff first and then we can move on to coding, hopefully from the next video. Okay, so about this video, machine learning, what are we going to learn in this video? We are going to learn three things: what, why, and how. That is, what is machine learning, why should we learn machine learning, and how do we actually implement machine learning. So these are the three questions which you should be able to answer by the end of this video. Right, so let's begin. Let's answer our first question. What? Okay, I made a mistake in writing what. Okay, so WHAT, what is machine learning? Okay, so to explain that, let me take a simple example. Let us assume we have a newborn, not a newborn, we have a 2-year-old and 2-year-old baby, and his name is Alex. Okay, so Alex wants to walk. Okay, he wants to walk, so he gets up one day, he brings enough strength within his legs and he tries to walk. So he tries to walk. Okay, so let me just zoom in a bit. Okay, this looks good. So he tries to walk. So what are the two possible outcomes when a newborn baby or 2-year-old starts or tries to walk? Right, he can fall. Okay, that can be either yes or a no. If he falls, what is he going to do? He's going to try again. Maybe he will do something differently this time. Maybe first time he took his left leg forward and fell down, so this time maybe he'll try to take the right leg forward. He'll try again. He falls. Yes, he tries again, and this cycle continues. It continues till finally he does not fall. So he does not fall for a long time and slowly gets comfortable in walking. So that is when he stops. Does he actually stop? No. When he doesn't fall, he doesn't start, he starts to walk comfortably. We'll take him out. Right? He has started to walk in his home on the floor. Let's take him out. Let's take him to the park. Let's take him to the garden. Let's see if he can walk on the grass. Well, if he falls there, he's going to try again. So this little example from our real life, which is very much relevant in anything which we do, be it walking, be it running, be it anything we do, be it learning about machine learning. We try, we have a task in hand, we try, we fail, we try again, we fail, we try again, we fail, and finally we succeed. And then we try to apply this knowledge again to unseen scenarios, right? So this is what basically machine learning is. We are trying to mimic what a human will do into machines, right? So to put it in technical terms, we can say Alex is the machine, right? Walking, this is the task in hand. The trying, failing, this part, this is the experience, right? When we fail, we gain experience. And from this experience, we learn and we try to do the same task in a different way. And this falling, whether he falls or doesn't fall, this is the performance. Okay, so performance P, experience E, and tasks T, and this is the machine, right? So put it in technical terms, there is one very famous definition of machine learning which I can put from this example, which we can infer from this example. So a machine is said to learn if a performance metric P increases with experience E on a task T. What does this mean? It means that as the machine performs a task T repeatedly, it gains some experience E, and with every iteration, with every trial of the same task, the performance of the machine increases. If this happens, then we say that the machine is learning. Machine learns. Okay. The important thing to note here is that this happens automatically. Here, when Alex was walking, trying, falling, and then trying again, no one was there to help him. He was doing it automatically by himself. No one was forcing him to walk. Similarly, a machine, when it is performing a task T, it is gaining experience E, and the performance increases automatically. It is learning automatically with the experience. When this happens, we can say that the machine is learning. So this is a very basic general definition of what machine learning is. To put it in a more relevant real life example, so if you use Gmail or any other mail for that matter, you must have seen something called a spam filter. There are some mails which automatically go into your spam folder instead of your inbox. So this happens with some machine learning algorithm. Slowly and gradually, the software, the machine which is there, it has learned that there are certain keywords in a mail. If there are certain keywords in a mail, then we can say that the mail is a spam. For example, if we have something called credit, if we have something called you have won some amount, you have won this much amount, okay, it is most probably a spam, right? If it has something called call now, this also can be a spam. So this is again a hypothesis. This may or may not be true. So if we try this, if the algorithm tries this and it sees that it is failing, it will gradually change the words which are actually present in spam, and gradually with experience it is learning that which words are actually there in a spam mail, and it is improving its performance of classifying the mails in a more correct way with more precision, right? So this is a very general thing about what is machine learning. So let's zoom out. So the other question in hand was, why should we learn machine learning? Again, a very important question. Well, if you're watching this video, then I hope that you already have some motive behind trying to learn machine learning. But again, I'll try to put it in more concrete manner, right? So why should we learn machine learning? Why is it required to machine learning in today's world? So if we see the utility of machine learning, the first and foremost thing which comes to our mind is automation. Like the example which we gave of spam filter. Suppose there was no spam filter first. What would happen? We would have thousands of mail in our mailbox and we have to manually classify them into spam or not spam. So instead of us doing the hard work, we have created a software which can do this for us. So that makes life easier. So life has become easier because of machine learning, and that is true for any scientific, any technical thing. The main motive behind any engineering, any technical thing is to make human life easier, and that is what machine learning is doing. So automation is a very important thing. Not only in spam filter, we can have automation of anything. We can have automation in detecting some specific activities using camera. We can have automation in detecting faces of different people, or detecting hand gestures, or anything, right? So automation is a big thing. Next, the important thing is there are many complex problems in this world which cannot be solved using the generic methods, the conventional methods which we have, right? There is no deterministic mathematical solutions to many problems in this world, right? So these complex problems, they have certain patterns within them which cannot be seen by human by itself, right? So we need some algorithms, some machines to help us to see them. Complex problems or complex patterns, we can say. Like machine learning is being used extensively in detecting cancer in patients. So we have images of tissues from human bodies, and we want to detect whether the patient has cancer or not. I'm not so strong medically, so I don't know if the example is right or not, but this is what happens. So a human may or may not be able to determine whether the patient has cancer or not, but just by seeing the images of the tissue. But a machine learning problem if it has been given enough data, and that is a very important thing. Data is the heart and soul of any machine learning problem. So if it has been given enough data, then the machine learning software or hardware or whatever it is, it can identify certain patterns within the images of the tissue for the patients who had cancer as opposed to patients who did not have cancer. So it can compare the images when it gets and can give you a prediction whether the patient has some cancer or not. So that is what can be used. Again, the third thing, prediction based on past data or current scenario or whatever is happening currently. It can be best explained using stock markets. Machine learning is being extensively used in the area of stock markets prediction. So if you want to predict whether this particular stock will go up or go down next day, you can put machine learning to use. It can detect many patterns which are otherwise not visible to us, which we cannot comprehend ourselves. It can detect many patterns, and you wouldn't even know what patterns exactly machine is detecting. So that can be right, it can be wrong, but that depends on how good your algorithm is. So it can detect many patterns and give very good predictions. So these are some of the many examples why we should learn machine learning, right? So it's of course the buzzword, it's being used extensively, and it is going to be used extensively in future also. Machine learning, AI, we hear this all the day now. Okay, so let's zoom out. So we have answered two questions: what is machine learning, why should we learn machine learning, and now let's move on to the most important part: how do we actually implement machine learning? Okay, let me use a blue color. So the question is, how do we implement machine learning? So there are different methods of implementing machine learning, and so we can broadly classify it into three groups. The first grouping can be done on the basis of how much human assistance is required. Human assistance. So how much human assistance is required to train a specific machine learning algorithm? On the basis of this factor, we can classify some algorithms. The next would be whether it can learn online. Whether it learns online. So whether it learns online, that means that when we are actually using the machine learning software, whether it is learning on the go or it has learned initially once and it is applying itself on the real life scenarios again and again without learning new things from it. So this is one point of classification. The third factor could be that is it instance based or is it model based? Right? So we'll get to what is instance based and model based in a while. So let's begin with how much human assistance is required. So on the basis of how much human assistance is required, we can classify machine learning into four main categories. We have something called supervised learning, right? Supervised, as the name suggests, it is something under supervision. So this is where maximum human assistance is required. We have something called unsupervised. Again, as the name suggests, unsupervised means that very less human assistance is required. We have something called semi-supervised, which falls between supervised and unsupervised. And the last one is reinforcement learning, right? So let's begin with supervised learning. So in supervised learning algorithms, machine learning algorithms, what we feed into the algorithm is the data plus the labels. So what it means is that we have a data, that means we have certain features. In machine learning we call it features. For example, if we want to predict that a customer in our mall, will he buy a specific product or not. We want to predict this, right? So for applying supervised learning problem algorithm, what we need to have is we need to have past data of customers who have bought that specific product and past data of the customers who have not bought this product. Okay, so let me try to write it over here. Okay, so we have customer data set. For customer, we have their age, we have their gender, we have their income. Suppose we have these three data for each customer, and we have whether they have bought the product or not. So we have some age, gender, income. He has bought the product, yes. Now next customer, we have his age, gender, income. Bought the product, no. Again, third customer, age, gender, income, bought, no. And this goes on. Suppose we have 1,000 such customers. We have data for 1,000 such customers. So here we can apply the supervised learning problem because we have the data for each customer and we have the labels. So this is called the labels. And this is called the data, or in machine learning we call it as features. Features for each instance 1, 2, 3, and goes on instance 1,000. For each instance we have all the features and we have the labels. Then we can apply the supervised machine learning problem, right? Okay, so that's about supervised. So to name a few examples, we have k nearest neighbors, we have something called support vector classification, we have MLP, the multi-layer perceptron, and so on. We learn all about this. We will learn how to code all these in future videos, so don't worry about them much for now. Okay, so let's move on to the next problem, next algorithm, that is the unsupervised. As the name suggests, or you might have guessed also, unsupervised algorithms do not have the labels. It only have the data. So how does this actually work, right? So we don't know what we are actually predicting. We don't know what the labels are. In unsupervised machine learning problem, what we'll try to do is we'll try to group certain features together. We'll try to see if there are certain groups, right? Let's try a customer problem again. Suppose we don't know whether, we don't want to predict whether the customer buys the product or not. We just want to group customers together, certain types of certain categories of customer together, and we want to see if there is any pattern in them and we can further decide the policy for them, right? Suppose I plot the age versus how much amount they spend in the mall. Okay, so we have some data points like this, and we have some data points like this, and we have some data point like this. So I have deliberately made this in different color, but you can obviously see that customers of this age group, they have spending score within this range. Okay, within this range. Again, customers of this age group, this specific age group, they have spending score within this range, and customer of higher age group, they have a bit higher spending range than the younger customers. So this is the kind of grouping which we can see within the data. So this was very easy to see from naked eyes, but when we have many such features for each customer, this is difficult to visualize, and that is where machine learning helps us. So instead of predicting anything, it is going to group similar things together, and it can help us identify different patterns within the problem. So that is what unsupervised learning is about, right? We don't have labels, we only have data, and we are trying to see different possible groupings within the data. And if we talk about semi-supervised learning, again, that is somewhere in between supervised and unsupervised. So that is, we have some data have labels and some do not have labels. More number of data does not have label. Okay, an example of this can be, let me write it over here. So if you have used Google Photos, right? So Google Photos, suppose you upload many pictures on Google Photos, it can determine that the same person is there in photo number 1, in 2, in 5 and 7. It has detected that the facial features of the person in photo 1, 2, 5, 7 is same. So it says that same person in all these photos, and Google Photos wants to label them. He wants to know, the software wants to know that who the person is. So only for one photo, if you label that this person is Alex, Google Photos automatically determines that the same person was there in 1, 2, 5, 7. So it can automatically label that in photo 2, 5 and 7 the person is Alex. So that is what unsupervised learning is. You give label for only some data and you do not label rest of the data. That is done automatically by the algorithm. And when we come to reinforced learning, the reinforcement learning, you would see that if there are many machine learning problems which are being applied to playing games, that is where we use reinforced learning. In reinforced learning, we have a task in hand. Suppose when we are playing a simple game, let me draw simple tic-tac-toe. So suppose the user draws a cross over here. So machine learning algorithm will determine whether what the next step should be. So suppose the machine draws a circle over here, user draws a cross again, and machine learning algorithm now have to decide where to draw the circle. So if it draws a circle over here, it is saved. If it draws a circle anywhere else apart from here, the algorithm loses. So suppose just a second, yeah, suppose the algorithm draws a circle over here, user draws a cross over here, and the user wins, right? So the algorithm will learn that when the situation was this, that a cross over here, and a circle over there, if it draws a circle over any of these grids, any of these blocks, then it loses the game. So it learns, it penalizes itself that drawing a circle over here is not the right thing to do. So with many iteration, it will slowly determine that drawing a circle over here is the right choice, because if he draws over here, he doesn't lose, so he rewards himself. So in reinforcement problem, we have something called reward and we have something called penalties. So the aim is to maximize rewards and reduce the penalties. So that is how reinforcement learning works. Okay, so that was the first criteria of classification, data based on how much human assistance is required. So next we can move on the rest of the tools classification. Not much to tell about them. So the second one was whether the machine can learn online or not. So it can learn online. It does not learn online. So some algorithms which can learn online was like the example I gave of the spam filter. So suppose there are certain list of words based on which the algorithm is deciding that the mail is spam. And suppose the sender of the spam knows that these are the words which can trigger the algorithm, so he slowly changes the word. So if the algorithm does not learn online, it will let go the rest of the mails, and the accuracy of the program decreases. So if it can learn online, so while it is deployed already in real life, it can still keep on learning and improving itself. So that is how online working works. If it doesn't work online, that is simple. It trains on specific data, and then it is deployed in real life. So after deployment, it does not learn any further. So that is when the machine learning algorithm does not learn online. And the last one was whether it is an instance-based model, or it was model-based, right? What is instance-based? So again, if I go to the previous example I gave, this one. Okay, now suppose we grouped the customers of different age group together based on their spending score and age, right? So suppose a new customer walks in and his age is somewhere here, right? So if his age is here, we are most likely to group the person in this group, in this age group. We can number them group number 1, 2, 3. So most likely this person belongs to group 3. Okay, and with a less probability to group 2, and with the very least with the very small probability to group 1, right? So if we want to determine in which group this person belongs to, we need to have the previous data of group 1, group 2, group 3. We need to have all these value points with us, and then only we can determine to which group does this person belong. So this is an example of instance based learning. Instance based, right? Like I said earlier, each different customer in this data, each one is a different instance. So we need to have all the instances with us all the time to characterize, to group a new instance which is arrived to us for the algorithm to work. So this is an instance based algorithm. If we, on the contrary, if we have something called model based, so that would be something like this. So let me give an example of model based, a very simple example. Okay, so we have some feature x and we have some feature y, and we have two types of points. So this is one type of point and this is the other type of point, right? So this is one type of data, this is other type of data. Okay, to make it more convenient, let me say that x is the petal length of a flower, right? Y is the petal width of a flower. Okay, and the blue one is a rose and the red one is let's say lotus. So now when a new flower comes to us having a certain petal width and certain petal length, we want to characterize, we want to classify whether it is a lotus or a rose. So it's quite visible to us right now that if we draw a straight line from here, so this line is dividing lotus and rose within this feature space, within this x and y space where we are plotting petal width as versus the petal length. So if we have the equation of this line, the equation of this line is going to be something like y equal to mx plus c, right? That is the equation of any straight line. So if we have the equation of this line, then we can know any value less than this line, that will fall here in the rows. Any value greater than the y equal to mx plus c falls in the category of lotus, right? So this line divides the whole space into two halves, and one half has all the lotus, the other half has all the rows. So we want to learn the equation of this line, right? We want to learn this. So that is what the algorithm does for us. That is what machine learning algorithm does for us, right? We don't need to do some geometry or something else to determine what is the value of m and c here, but rather the machine learning algorithm will automatically learn what is the value of m and c, right? So this is what learning is. So based on this training data which we have, all these instances of lotus, all these instances of rows, the machine learning will learn the values of m and c, and it will have the equation y equal to mx plus c. After this, when we want to classify some new data, some new petal length and petal width of flower determined by this x over here. So if you want to classify whether this is a rose or lotus, we don't need these data points of rose and lotus anymore. All we need is the equation of line, and then based on this we can classify it. If it falls on this side of the plane, it is a rose. If it falls on this side, it is a lotus. So this is a model based learning. This is a model based learning. So we train a model, and then based on the model we finally implement it, and we decide whether the new instance falls on one side or the other side, right? This is model based learning. Okay, so I think I've covered what we aim for this video. We have answered 3 questions. Where are the questions? Just a second. Okay, so we have answered how of machine learning, how to apply machine learning. We have answered what is machine learning, and we have answered why should we learn machine learning. So these are the 3 things to introduce while we start with machine learning. And from the next video, I think I'll start with a bit of code and a little bit of theory. We'll start with a very simple examples with very simple, very common data sets. And by the end of this whole series, I hope that you will learn about machine learning at least as much as I do. And with that, I'll end the video. Do put in the comments what would you like me to do, what would you like me to post in this series, or anything else which you want to suggest. Feedbacks are welcome. Do share, like, and subscribe. And that's it. Thank you. Thanks a lot.